You didn't click on this because you scare easily. By now, you've seen enough headlines about doomsday comets to know most of them are noise. But this one felt different. 3I Atlas versus Earth. What is the worst thing that could happen on December 19th? That title poked at the part of you that still looks up at the night sky and wonders if the universe is about to do something you do not want to miss. You're not here for panic. You're here because you like to know what is actually going on. You want the real picture, not the dramatized one. You want to understand, in steady, grown-up terms, what December 19th really means for you and the small blue planet you've spent decades building a life on. And you want to do it in a way that lets your shoulders drop, not tense up. So let's start with the simple truth. On December 19th, Earth is not in danger. There is no hidden collision course, no secret impact scenario. 3I Atlas will pass at a distance of roughly 170 to 180 million miles from Earth, more than 700 times farther than the Moon. It will not touch you, your family, your city, or your sky. And yet, this is still one of the most important close passes you will ever live through. Because 3I Atlas is not just another comet from the outer reaches of our own system. It is an interstellar comet, a fragment from another star system altogether. It has been drifting through the dark between stars for billions of years, older than our sun, older than the ground under your feet. At the end of October, it slipped through its closest point to the sun, and something interesting happened. It brightened faster than models predicted. Its tail shifted shape more than once. Spacecraft around Mars and solar observatories picked up details that did not quite match expectations, enough to make scientists turn more instruments toward the same moving speck of light. That is why December 19th matters. Not because of what could happen to Earth, but because of what could happen to our understanding. Right now, teams around the world are getting ready. Ground telescopes will measure how its brightness changes night by night. Spacecraft in orbit will track its gas and dust as it glides away from the sun. Spectrographs will pull apart its light to read the fingerprints of its chemistry. And everyone watching is waiting to see whether 3I Atlas quietly fits into our existing picture of the universe or forces us to redraw part of it. For you, the worst thing that could happen on December 19th isn't a disaster in the sky. The worst thing is much quieter than that. It is that something genuinely important happens and you slip past it half aware. That a moment your grandchildren might one day read about in astronomy books passes by, while you're lost in the usual cycle of emails, deadlines, and headlines. The worst thing is not impact. The worst thing is indifference. There is another kind of worst case too, one that makes scientists uneasy in a different way. The worst case, in a scientific sense, is that 3I Atlas refuses to behave exactly the way our equations say it should. That its chemistry looks just a little too strange. That its brightness curve refuses to match the models. That its path, after it swings past the sun, shows a tiny deviation we cannot fully explain with our current understanding of ice and rock and sunlight. Not proof of anything supernatural. Just enough of a mismatch to make experts sit back and say, "We're missing something." You know that feeling in your own life. You reach an age where you think you roughly know how things work. Then something happens that doesn't fit the pattern and forces you to reconsider the map in your head. The universe works the same way. Every once in a while, reality hands us an object like 3-Eye Atlas and says, "Here, try fitting this into your story." That is why you clicked. Not because you expect fire in the sky, but because you suspect there is more to this than most people are hearing. You want the full picture, without alarmism. You want someone to walk you through what scientists actually know, what they are honestly uncertain about, and what December 19th is likely to change or confirm. This story is here to give you that at a pace your mind can rest inside. We will follow 3-Eye Atlas from the night it first appeared as a faint moving point on a survey image, through its swing past Mars and the Sun, to its closest approach to Earth and its long exit back into the dark. So take a slow breath. Let your jaw unclench. Let your shoulders drop. Outside, the same sky you grew up under is still there, steady and calm. Far beyond what your eyes can see, 3-Eye Atlas is already on its way to that December encounter. You are safe. Your world is safe. And if you stay, you will understand why this date, this object, and this quiet question are worth your attention. This is not a story about the end of the world. It is a story about where your world sits inside something much larger. And it begins with how we first met this visitor from another star. You first met 3-Eye Atlas long before you ever heard its name, long before headlines appeared, long before anyone whispered the words interstellar comet. The story began quietly on the night of July 1st, 2025, in a desert valley in Rio Hurtado, Chile. While you were probably driving home from work, finishing dinner, or settling into your evening routine, a survey telescope was scanning the sky the way it always does. Frame after frame, night after night, looking for anything that moves in a way it shouldn't. That night, it found something. It wasn't bright. It wasn't dramatic. It was a faint, blurry speck drifting across a star field. The kind of thing most people would scroll past without noticing. But its motion was wrong. It wasn't following the gentle curve of a typical comet bound to the sun. It wasn't matching the path of an asteroid from our own backyard. It was moving faster than expected and at an angle that didn't fit anything familiar. The automated system flagged it. The astronomers double-checked. And by the next morning, that faint smudge had become an official alert. The coordinates and the first measurements were sent to the Minor Planet Center, the clearinghouse where the world's observatories share discoveries. MPC did what it always does. It compared the object to the massive database of known asteroids, comets, and artificial objects. And when it didn't match anything, the MPC sent out what astronomers call a circular, asking other observatories to help confirm the sighting. That is when the story deepened. Telescopes at Zwicky in California and additional Atlas units in Hawaii and South Africa began to check their archives. They looked back through images that had already been taken, pictures from late May and June, long before anyone knew a discovery was waiting inside them. And in those older images, they found it, the same speck, the same motion, hiding in plain sight. That told astronomers two things. First, the object wasn't a fluke or a glitch. It was real. Second, it was following a path unlike anything native to our solar system. When researchers took all the positions and ran the first orbital solutions, the numbers that appeared were unmistakable. Hyperbolic trajectory, extreme eccentricity, a velocity inbound that exceeded 58 kilometers per second, faster than almost any comet born in our own system could be. Those three ingredients together meant only one thing. The object wasn't from here. At first, it went by the temporary designation A11PL3Z, a name only a computer could love. Then, as the orbit became clearer, it received a more formal label, C1225N1, Atlas. And finally, when confirmation came that its path was truly interstellar, another upgrade arrived, 3I, Atlas, the third interstellar object ever observed visiting our solar system. Just 3, across all of human history. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 times, the universe sent us a traveler from another star. And you are alive for all 3. But the fact we found it at all carries a twist. Most sky surveys avoid the densest parts of the Milky Way because the star fields are too bright, too crowded, too complicated. But Atlas, the telescope system, is designed differently. It scans almost everything. It looks straight through the thickest glow of the galactic plane, and that is exactly where 3I Atlas was hiding, in one of the brightest, busiest stretches of the sky, where most surveys look away. It wasn't supposed to be found there. It was tucked into the glare like a moth in a floodlight, nearly invisible to every system except the one built to notice the things others miss. And that is how a fragment of another solar system slipped into ours and was caught in the act. You might think discoveries like this are loud, sirens, alarms, dramatic announcements, but the truth is quieter. It was just a few astronomers checking comparison frames, a few computers calculating orbital curves, a few researchers tapping numbers into software while the rest of the world slept. But when those numbers stabilized into a hyperbolic orbit, everybody who understood what it meant felt that same spark. A piece of another solar system entered ours while you were at work. That's the part no one tells you. How ordinary the moment feels while something extraordinary happens above your head. You go through your routine, answer your emails, pick up groceries, and meanwhile, a 4-billion-year-old traveler from another star drifts past Mars on its way to the Sun. In the days that followed, astronomers compared Atlas to its predecessors. Oumuamua, small, strange, no coma, moving like nothing we had ever seen. Borisov, unmistakably comet-like but unusually pristine, as if it had been frozen for eons in the dark. Atlas seemed different from both. Larger, brighter, active, with a coma that grew slowly and a path that cut through the solar system at an angle sharper than expected. It wasn't following anyone's script. The deeper scientists looked, the more clear it became. This wasn't just another icy wanderer. It was something older, something shaped by a different star, a different disk of gas and dust, a different history of heat and radiation. Every detail hinted that Atlas carried its own biography, one that began in a place we will never visit. And all of it started with a faint smudge in an image from Chile, a small blur that opened the door to an entire star system we will never see directly. A reminder that the universe does not revolve around us, yet still offers us these glimpses when we are paying attention. A lesson hidden in a single pixel moving across the sky. every strange detail we found later. The chemistry, the behavior near the sun, the unexpected brightness. All of it started right there, in that quiet July discovery. And that discovery was only the beginning. Because once astronomers knew where Atlas came from, the next question was obvious. What exactly is it made of? Now that you know how we first caught sight of 3I Atlas, it helps to pause and really look at what this visitor is. Not just where it came from, but what kind of thing has wandered into your neighborhood after such a long journey. If you could hold a snapshot of its statistics in your hands the way you'd hold a report at work, the numbers would tell you a story that is hard to forget. Start with speed. When 3I Atlas swept into the inner solar system, it was moving at roughly 150,000 miles per hour, about 67 kilometers per second. That is fast enough to circle the Earth more than 6 times in 1 hour. Most comets born in our own solar system never reach those kinds of speeds unless they are flung inward by a very specific gravitational setup. This one arrived already moving that quickly, before the sun really had a chance to touch it. That alone marks it as something different. A traveler that has spent a long time falling through the shallow gravity wells between stars. From that speed and the way it approaches, astronomers can estimate something like a dynamical age, a measure of how long an object has been wandering the galaxy rather than orbiting one particular star. For 3I Atlas, that age stretches back 7, maybe 8 billion years, older than the sun, older than the Earth, older than the oceans and the continents and the rocks under your feet. When you picture it sliding past our system, you are not just watching ice and dust. You are watching a memory, a fragment of a planetary system that may have formed and died long before our own ever lit up. Then there is the chemistry. When we look at a comet, we are really looking at what happens when sunlight wakes up frozen material. As 3I Atlas moved closer to the sun, spectrographs began to pull apart its light, revealing lines that correspond to different gases. The pattern that emerged was familiar in some ways and unsettling in others. There was carbon dioxide, a lot of it. The comet seemed unusually rich in CO2 compared to many comets from our own Kuiper belt and Oort cloud. There were traces of nickel vapor, hints of carbonyl sulfide, and the telltale signatures of cyanide-bearing compounds. The mix looked like something we know, but with the knobs turned just a bit too far in certain directions. If you have ever visited another country and tasted a dish that reminded you of something from home, same ingredients, different proportions, you know the feeling. 3I Atlas has that same effect on planetary scientists. It is built from the same basic cosmic pantry: carbon, nitrogen, oxygen, metals, ices. But the recipe is off just enough to suggest it was frozen into shape in a very different kitchen. Perhaps further from its parent star, near a line where carbon dioxide, rather than water, was the dominant ice. Perhaps in a system with a dimmer, cooler star. Wherever it formed, the ratios of its gases whisper, "I did not grow up here." Look at its color, and you see the passage of time written on its skin. Images and brightness measurements show a reddish tint, more pronounced than many local comets. That color doesn't come from paint. It comes from radiation. Over billions of years, High-energy particles and ultraviolet light break and rearrange molecules on the surface, creating darker, redder organic residues. You are essentially looking at a surface that has been slow cooked by the galaxy for longer than life has existed on Earth. Every grain of dust that the comet sheds carries that history with it. Even the way 3I Atlas spins tells you something. By tracking subtle changes in brightness as it rotates, astronomers estimate a rotation period of about 29 hours. That is a lazy, unhurried spin, compared to many smaller comets and asteroids, which can tumble in just a few hours. A slow rotation suggests a relatively large, heavy nucleus whose mass has resisted being twisted into a faster spin by jets of sublimating gas. This is not a tiny shard. This is a sizable body, perhaps 10 kilometers across, an iceberg of alien stone drifting through your solar system as if it were nothing more than a puddle in its path. In the weeks leading up to and after its closest point to the sun, its brightness curve told another part of the story. During September and October, 3I Atlas brightened steadily, in line with, and then slightly ahead of, model predictions. It was not exploding with activity the way some comets do, but it was not quiet either. It behaved like something that still had plenty of frozen material to burn off, even after billions of years in the dark. Then, near perihelion and beyond, its coma and tail began to shift. Structures in the tail changed shape more than once. The exact way gas and dust peeled away from the nucleus didn't match every line on the charts. Nothing dramatic enough to shout, "Impossible," but enough to make people lean closer to their screens. Put all of this together, and a picture starts to form. You are not dealing with a simple ball of dirty ice that just happened to wander in. You are looking at a layered object that has survived ejection from its home system, endured eons of interstellar radiation, and still carries intact pockets of gas and ice that can light up under a new sun. You are looking at the leftovers of a planetary disk around another star, preserved like a time capsule and delivered to your doorstep at 70 kilometers a second. When you hear the word comet, it is easy to imagine something generic, interchangeable. One dusty snowball much like another. But 3I Atlas refuses to be generic. Its speed says, "I have been traveling a long time." Its age says, "I was here before your sun turned on." Its chemistry says, "I formed in conditions you can only infer." Its color says, "I have faced the galaxy alone for ages." Its slow spin and steady brightening say, "I am still very much intact. Why does an object older than the sun end up here now, while you are alive to see it? Why this particular mix of gases and metals? Why this speed, this path, this moment in history?" No one can answer that fully. The galaxy is not obliged to give reasons that satisfy human timing, but you can recognize the privilege built into the coincidence. A traveler older than your star is passing by once. This is why scientists are paying such close attention, and why December 19th becomes so important in this context. All the oddities, the speed, the age, the chemistry, the behavior near the sun, will feed into the measurements taken as 3I Atlas makes its closest approach to Earth's orbit. The way its activity changes with distance, the way its tail responds to the solar wind, the way its brightness rises and falls as it recedes. Each of these will either fold neatly into our understanding or push against the edges of it. These anomalies will matter on December 19th. They are the difference between a comet that quietly confirms what we think we know and a comet that nudges us into admitting we still have a lot to learn about how other solar systems build and scatter their debris. You are not just listening to trivia. You are listening to the dossier of a witness, a piece of physical evidence from a case file written in another star's language. And the next part of the story is about how this witness has moved through your solar system, threading past Mars, the Sun, and eventually the orbit of Earth. To understand what could happen on December 19th, you need to follow Atlas's path, step by step, through your own celestial neighborhood. If you could watch the path of 3i Atlas as a slow-moving film, you'd see a journey that looks almost intentional. Not guided, not directed, but graceful in a way only nature can produce. Every step along its path through the solar system has the rhythm of a traveler passing through foreign towns without ever stopping, glancing at each one only long enough to leave a trace. The first major waypoint came on October 3rd. On that day, while you went about your life, maybe driving to work, maybe mowing the lawn, maybe dealing with something at home you didn't have time for, 3i Atlas passed near Mars at a distance of just under 0.19 astronomical units, close enough that the spacecraft orbiting Mars had a front row seat. The Mars Reconnaissance Orbiter took images of the widening coma. MAVEN measured particles drifting from the nucleus. China's Tianwen-1 mission caught glimpses of the tail as it stretched behind the comet like a ribbon pulled across the void. It is strange to think that machines circling another planet were watching this traveler before most people on Earth even knew its name. 3 robotic observers, silently tracking an object that had already spent billions of years alone, now brushing past the world we dream of visiting. From Mars, Atlas kept falling inward. The sun's gravity drew it down the slope of the inner solar system toward its closest approach, its perihelion, on October 29th and 30th, at a distance of roughly 136 to 1.4 astronomical units. Not dangerously close, not brushing the sun's outer atmosphere, but close enough to wake its ices and sweep its tail into long arcs. Closer than expected, it brightened in the days before perihelion, as if responding to its first real sunlight in eons. And then, suddenly, it vanished. Not because it faded, not because it broke apart, but because it slipped behind the sun from Earth's point of view. A natural alignment called solar conjunction pulled it into the glare, where no ground-based telescope could safely track it. For days, even the most dedicated observers could only wait. You can imagine that quiet, collective pause. Scientists checking their models, updating predictions, wondering whether they would still see it afterward. And then the sun released it. When 3i Atlas emerged again in mid-November, it returned brighter than many forecasts suggested. The sun had not consumed it. If anything, the encounter seemed to have energized it. Instruments watching from space noticed the coma looked a little fuller. The tail, oddly, appeared reshaped. That wasn't supposed to happen quite that way. Even SOHO, the solar observatory spacecraft used primarily to monitor solar storms, picked it up when predictions suggested it shouldn't. No fireworks, nothing supernatural. Just a reminder that an object shaped in another star system does not always obey the expectations born from ours. Around this time, the comet's path brought it near Venus, not close enough to threaten, but close enough that the geometry gave astronomers a new angle. And that was when something unexpected occurred. A blast of solar wind seems to have torn at the comet's tail, stripping long streams of dust and gas away like thread pulled loose from fabric. Days later, the tail appeared rebuilt, not identical, but reformed from new material rising off the nucleus. For something drifting through space at tens of kilometers per second, this act of destruction and renewal was almost serene. As November deepened, 3I Atlas began angling toward the part of the solar system that Earth occupies, though still at a safe and predictable distance. If you could see its orbit drawn out in 3 dimensions, you'd see how odd it looks compared to comets native to our system. Its trajectory is sharply inclined, cutting through the flat plane of planets like a knife slicing diagonally through a stack of pages. And because it is retrograde, it moves opposite the direction Earth and most planets travel. It is truly a foreign visitor, following a route no local comet would normally take. There is something poetic about watching a path like that, even if only in animated models and orbital diagrams. A lone traveler crossing the busy lanes of the solar system, uninterested in the traffic patterns of the worlds around it. A reminder that not everything moving through the universe is meant to align with what you already understand. A reminder that some things walk their own road. Why did Soho see it when predictions said it shouldn't? Why did the tail shift shape twice? Once before perihelion, once after. No one can answer those questions fully yet, but these details matter. They show that 3I Atlas is active, reactive, and expressive in ways scientists are still learning to interpret. And every step brings it closer to December 19th. The truth is, 3I Atlas has already passed close to more worlds than most people realize. Mars watched it first. Venus watched it later. Spacecraft near the Sun glimpsed it in passing. And now, its path is bringing it into position for Earth's turn. Not for danger, not for drama, but for clarity. If you picture its journey from the moment it crossed into the solar system to this point, it looks almost like a stitched line through a wide map, weaving near Mars, diving toward the Sun, slipping behind it, reappearing brighter, brushing the orbital neighborhood of Venus, then gliding toward the region where Earth orbits. A perfectly timed intersection, even if that intersection occurs across a vast, safe distance. There is a line by Arthur C. Clarke that fits here. The only way to discover the limits of the possible is to venture a little past them. Whether he meant it as encouragement for humans or a commentary on the universe itself, it applies to objects like this. 3I Atlas is not testing its limits. It is simply following the momentum it was given billions of years ago. But in doing so, it pushes the limits of what we can observe, what we can measure, and what we can understand. As you follow its path, what becomes clear is this. 3I Atlas is not silent. It reacts to sunlight, to radiation, to the solar wind. It brightens, it shifts, it regrows its tail. It is alive in the same way all comets are alive. Not conscious, but responsive, shaped by every force it encounters. And because of that, its journey becomes more than just a line on a chart. It becomes a conversation, a back and forth between a visitor from another star and the environment of your own. It slipped behind the sun and came back different. Its reappearance changed everything observers expected. Because if an object transforms slightly each time it interacts with the forces around it, then the way it behaves on December 19th will also hold meaning. Not dramatic meaning, not dangerous meaning, but scientific meaning. Clues about its structure, its origin, and its story. By the time you finish following this part of its journey, you can feel why scientists are waiting, watching, preparing, why this moment matters, why the approach of December 19th carries not fear, but anticipation. The next step is the one you probably care about most. Now that its path is clear, what exactly will happen on December 19th? When you hear a date like December 19th, linked to an interstellar comet, it's natural for your imagination to reach for something cinematic. A streak of light across the sky, a glowing object near the horizon, a moment that looks like it belongs in a movie trailer. But the truth, the real truth, is quieter, gentler, and far more meaningful than anything Hollywood would script. December 19th won't give you spectacle. It will give you perspective, and that's worth more. So let's answer the question directly. The one sitting at the front of your mind. What will you actually see on December 19? First, the distance. 3i Atlas will pass Earth at roughly 1.7 to 1.9 astronomical units. The range will tighten as we get closer, but that is the neighborhood. If you prefer simpler terms, that is more than 700 times the distance between the Earth and the Moon. It is far. Farther than Mars was when it watched Atlas pass by. Farther than any world that could feel a tug or a threat. But for an interstellar comet, which could have skipped past us entirely and left no trace in human instruments, this is extraordinarily close. The closest that an object from another star has ever come to our world in all recorded history. And that is why December 19th matters. Not because of what could happen to Earth, but because of what Earth gets the chance to see. If you step outside that night into your backyard, breathe the winter air, and look up, you will not see 3i Atlas with your naked eye. There will be no glowing streak, no sudden flare, no sign that a visitor older than the sun is slipping past your planet. And that is okay. The night sky has never owed us fireworks. But if you own a small to medium backyard telescope, and if you live under a sky dark enough to show the Milky Way, you might catch it. A faint smudge of light, a soft blur with a fuzzy edge, no brighter than a ghost of starlight drifting through the field of view. It won't shout for your attention. It will whisper. And that whisper is enough. Professional observatories, of course, will see more. With long exposures and sensitive instruments, they will detect the coma, the thin halo of vaporized ice surrounding the nucleus, and they will track the brightness day by day, looking for any change that tells them the comet's activity is rising or fading. Some observatories may catch hints of the tail, especially the ion tail that responds to the solar wind like a windsock on a distant runway. But even for them, this is not a photogenic object. It is a scientific one. And that brings us to what will truly happen on December 19th. While the sky above your house stays quiet, the world's observatories will be humming. Telescopes from Hawaii to the Canary Islands, from Chile to South Africa, will be scheduled to track the comet as Earth rotates. Live streams will run for hours, broadcasting real-time images and brightness curves. Spectrographs will collect the chemical fingerprints of escaping gases, measuring carbon dioxide, water vapor, dust, and trace molecules with the precision of a heartbeat monitor. Some teams will watch for how quickly Atlas settles down after perihelion. Others will analyze the structure of its tail, looking for clues about the solar wind's impact. Scientists will study these numbers the way you study the face of someone you haven't seen in years, looking for signs of change, signs of stress, signs of a story written in subtle lines. Every piece of data will carry meaning. Every pixel will be a clue. And you'll be home. Picture it for a moment. It's a cold December evening. You come back from work, maybe later than you meant to. You hang your coat. You warm your hands. You sit down in your favorite chair, the one that has shaped itself slightly to your weight over the years. You open your laptop or your TV. Somewhere in the recommended list is a thumbnail. Lev, 3i Atlas, Interstellar Comet, closest approach to Earth. You tap it. On your screen, the view appears. A star field, a dark background, and in the center, a dim spot. A small object, almost unremarkable in appearance. You might think, that's it? And then slowly, the meaning settles in. That tiny smudge traveled billions of years to cross your sky tonight. It left its home system before Earth existed. It wandered the black between stars, while civilizations rose and fell, while oceans formed on Earth, while forests grew, while the first humans walked upright. And tonight, you get to witness it. You, sitting in sweatpants in a warm room on a cold night, get to watch a once-in-a-species event from the comfort of your couch. No other generation before you saw something like this. No generation after you will see this exact object again. Your grandchildren won't. Your great-grandchildren won't. This is a one-night-only passage, a brief intersection of cosmic timelines. That is the wonder of December 19th. It is not about fear. It is about belonging. Belonging to a moment in the universe's story that only your era gets to experience. Belonging to a species that can now live stream a comet from another star. Belonging to a world where scientific instruments can turn a faint dot into the foundation for new models of interstellar chemistry and planetary formation. Because the data collected that night will matter, not only for the beauty of the images, but for what those images will teach us. How interstellar objects are built, how they respond to sunlight, how common or rare these visitors might be, and what this says about the systems that lie beyond our reach. So what will you see on December 19? You will see a quiet sky. You will see a faint smudge on a screen. You will see scientists doing their best work, and you will see yourself, a calm witness to a moment the universe rarely offers. You'll feel that strange mix of smallness and privilege that only astronomy gives. The same feeling that draws you to videos like this at the end of long days. The same feeling that helps your mind slow down. The same feeling that lets you sleep a little deeper afterward. This is the closest an interstellar comet has ever come to Earth, and we are watching it from our couches. Stay with this story, and by the time December 19th arrives, you'll know exactly what you're looking at and why it matters. If nothing frightening will happen in the sky, then what exactly are people afraid of when they hear comet and December 19 in the same sentence? At some point in this story, a question rises quietly in the back of your mind. The same question millions of people have whispered to themselves while scrolling the news or watching clips online. You may not say it out loud, but you feel it. So let's put it on the table, plainly and without drama. Is 3i Atlas dangerous to Earth? The simple answer is no. Not in the way you might instinctively imagine. Not in the way history books or disaster movies have trained you to picture. And definitely not in a way that involves impact, chaos, or fire in the sky. Let's clear the biggest misunderstanding first. The orbit of 3i Atlas does not cross Earth's orbit. It doesn't come close. It doesn't thread the needle in a way that risks collision. At its nearest, it will be more than 700 lunar distances away. A span so wide that even the most imaginative storyteller couldn't twist it into danger. And because it's an interstellar object, it's moving so fast on such a precise hyperbolic path that nothing, not gravity, not planets, not magnetic fields, can yank it suddenly toward Earth. Objects like this don't change course. They don't have engines or intentions or hidden abilities to shift direction. Their path is locked in by simple physics, and that path takes it safely past our world. Once you understand that, the next layer of fear is usually more subtle. You've seen comments online. Will it cause strange magnetic storms? Could it disrupt the atmosphere? Could its tail sweep across Earth? Could it bring something harmful with it? None of those fears hold up. The magnetic influence of a comet is negligible compared to the sun, which flares in storms and erupts constantly without ending civilization. A comet's coma is so thin that if you compressed it, it could barely fill a bottle of air. Its tail, even if it stretched millions of miles, would pass nowhere near Earth. And even if it did, you would walk through it without knowing. The tail of a comet isn't a solid whip of fire. It's microscopic dust and faint ions too diffuse to even register on human skin. And yet, even when the science is clear, something in us still tenses when we hear the words comet in December and close pass. That tension isn't ignorance, it's instinct. Humans are built to respond to objects moving fast toward us. It's a survival trait older than language. A flash in the sky, a streak of motion, a shadow crossing the sun. Our ancestors learned to react first and think later, because sometimes thinking later meant not surviving at all. That wiring never left us. It just modernized. Now the same pulse of alertness activates when we see troubling headlines or out-of-context clips, and there's history behind that anxiety. For thousands of years, comets were seen as omens, symbols of war, famine, misfortune. Entire civilizations watched the sky with dread, believing these glowing visitors carried consequences. Even once science replaced superstition, the emotional echoes stayed behind. You can know the facts, you can understand the math, and still feel your stomach tighten just a little when you hear about a comet approaching. But here's the difference between then and now. In 2025, we don't beg gods for mercy. We don't burn offerings or build monuments to ward off cosmic danger. We use telescopes. We use spectrographs. We build simulations that run for millions of iterations until the uncertainties shrink to nothing. We test scenarios, validate them, share the results across continents. This isn't guesswork. It's measurement. It's engineering. It's quiet competence. So, if impact isn't what you should fear, what is fear, really, for someone your age? For a grown man, someone who's weathered enough storms in life to know the difference between real threats and imagined ones, fear often comes from somewhere more personal, not from explosions or falling rocks, but from feeling like you don't have control, from facing something too big, too distant, too complex to fit into your existing mental model, from the sense that the world is shifting faster than you can update your understanding. And that's the truth hidden inside this moment. The worst thing 3i Atlas can do to you isn't physical, it's cognitive. It may challenge an assumption. It may reveal something unexpected about interstellar objects. It may force scientists, and by extension, all of us, to adjust the map of what we thought we knew. For many people, that's the uncomfortable part. Not danger. Disruption. Not destruction. Revision. But revision is how science grows, and how understanding deepens. And none of this touches your daily life. Your mortgage isn't threatened by this comet. Your job isn't threatened. Your family plans, your schedule next week, the heat running in your house, the car you'll drive tomorrow morning, all of that remains fully, comfortably unchanged. The universe does not intend to interfere with your responsibilities. What December 19th offers you isn't fear, it's clarity. It's a chance to watch the universe behave in real time, and to watch scientists make sense of it without panic, without mythology, without superstition. So what should a grown-up, science-minded person actually worry about? Not impact, not danger, not catastrophe. The only thing worth fearing, if fear is the right word at all, is missing the lesson this visitor carries. The insight, the chance to see a real interstellar object up close, scientifically, thoughtfully, calmly, and walk away a little wiser about the universe you live in. In the words of Carl Sagan, there is no hint that help will come from elsewhere to save us from ourselves. And this comet is another reminder. The universe isn't here to harm us or rescue us. It simply offers us chances to understand. What we do with that understanding is up to us. So if we're not afraid of impact, what should a grown-up, science-minded person actually worry about on December 19th? Imagine waking up one morning and discovering that the mental map you've carried your entire life is missing an entire continent. Not a small island. Not a corner you overlooked. A continent. Something vast, significant. Something that forces you to redraw everything you thought was settled. That is the kind of worst case we're talking about now. Not danger. Not doom. Not anything physical at all. We're talking about a different kind of disruption. The kind that happens inside the mind. The kind that forces you to update your understanding of the world and your place in it. Everyone carries a map of the universe in their head. You do too, whether you think about it consciously or not. It's built from what you learned in school, what you saw in documentaries, what you picked up over years of curiosity. On that map, comets form from icy debris around young stars. Their chemistry follows certain rules. Their behavior follows predictable models. Interstellar objects, when they wander into our neighborhood, should act in ways that align with what we think we know about the galaxy. That's the map. But what if 3i Atlas draws a line right across it? Your inner map includes assumptions like these. Comets formed in cold outer disks, should carry familiar chemical signatures. Interstellar material should follow patterns shaped by star formation and galactic tides. After perihelion, an object should calm down, cool down, and fade in a predictable thermal curve. Outgassing should explain small deviations in its path. You didn't decide these assumptions. They came bundled with the understanding of astronomy your generation grew up with. They're the default settings, and now we arrive at the worst-case scenario. Not for your safety, but for your certainty. A worst-case December 19th might look like this. First, the spectral readings taken by observatories show chemical components that do not match any model of cometary formation. Not from the outer reaches of our solar system. Not from any theoretical interstellar environment we've modeled. Something genuinely new. Not alien. Not artificial. Just unexplained. Carbon ratios that don't fit the expected pattern. Nickel vapor in concentrations that make no sense. A signature molecule that appears out of place. Even a small discrepancy here would ripple through how we understand the chemistry of early star systems. Second, the brightness curve refuses to behave. Instead of fading as expected after perihelion, Atlas holds steady or even brightens slightly, defying the predictions of thermal models. Activity lingers longer than it should. The coma pulses with life scientists didn't anticipate. It is still entirely natural, but outside the framework our equations predicted. Third, after leaving the sun's vicinity, the comet's trajectory diverges slightly from the calculated exit path. Not enough to alarm anyone, but enough to say, something is happening we can't attribute to simple outgassing or solar radiation pressure. In a universe governed by gravity and momentum, even a small, unexplained nudge is a big deal. None of this would prove alien engineering or any exotic fantasies, but it would prove something humbling. We've been underestimating the universe. We've been relying on a map that is missing a continent, and to a grown-up, to someone your age, who has spent a lifetime believing that life is what it is. That kind of revelation is its own quiet shock. There's something uniquely unsettling about realizing the world is larger and stranger than the version you had settled into. But that feeling is also the beginning of wonder. And for someone who loves astronomy, it can be thrilling. History shows us that every major leap in understanding begins with a discomfort like this. When Einstein refined Newton's laws, physicists had to accept that space and time were far more flexible than anyone imagined. When the Big Bang replaced the idea of a static universe, humanity had to accept that everything, stars, galaxies, our own planet, had a beginning. These transitions weren't easy. They forced scientists to redraw the map, but they also expanded what we could know, what we could measure, what we could imagine. This is the terrain we're entering with 3i Atlas. Picture it like this. You've lived in your home for years. You know every room, every draft, every light switch. And then one afternoon, you notice a door you've somehow never seen before. Behind it is a staircase leading down. An entire floor you didn't know existed. Nothing dangerous, just unexpected. A quiet invitation to explore a place you didn't realize was yours to explore. That's the kind of worst case December 19th may bring. The possibility that 3i Atlas carries details that force planetary scientists to rethink how interstellar comets form. The possibility that its behavior writes a footnote in the textbooks your kids and grandkids will one day read. The possibility that this quiet visitor from another star forces us to accept that our understanding of the galaxy is only chapter 1 in a book with many unwritten pages. For most people, that level of uncertainty feels uncomfortable. But for someone who has loved astronomy for decades, someone who listens to videos like this because the universe helps their mind settle, this kind of worst case is the best kind. It means you are alive at the exact moment the universe chooses to reveal a new truth. In the words of Richard Feynman, I would rather have questions that can't be answered than answers that can't be questioned. That's the spirit of this moment. Not fear. Openness. Not panic. Possibility. The worst thing that could happen on December 19th is not danger. It is the realization that the universe is bigger, older, and more complicated than our equations dared to predict, and that we must expand our understanding to match it. A worst case that asks you to grow is still a gift. And for anyone who has followed 3i Atlas since its discovery, the truth is simple. If the universe forces us to update our map, we should feel lucky to be here for it. Lucky to witness the moment when the cosmos gently corrects us. And whenever reality stretches our maps, our imagination rushes in to fill the gaps. That's where the wild theories begin. Once you open the door to mystery, science fiction slips in quietly. You don't even notice the moment it happens. 1 second, you're thinking about carbon dioxide and orbital mechanics, and the next, some old corner of your mind whispers, but what if it's something more? It doesn't mean you believe it. It just means you're human. Curiosity is wired into you as deeply as caution. So let's take a small detour, a gentle one, into the realm of speculation. Not because the facts fail us, but because imagination has always grown in the spaces where data hasn't yet arrived. There is a famous idea in science fiction, the dark forest hypothesis. You may know it from Liu Cixin's novel, or just from conversations online. It imagines the universe as a vast, silent forest, cold, dark, filled with unseen hunters. Every civilization is one of those hunters, holding a rifle, careful not to make noise. Because in a forest full of predators, shouting your presence is the quickest path to becoming prey. You move quietly, you observe, you wait, and you never ever reveal your location unless you absolutely must. It's a haunting metaphor, one that forces you to look at the cosmos through the eyes of someone trying to survive rather than explore. And in that metaphor, if, and this is a very big if, a civilization wanted to check on younger, noisier species without drawing attention, how would it do it? Silent probes disguised as natural objects would be the perfect answer. Something that looks like a comet. Something that behaves enough like a comet to slip through undetected. Something encased in ice, timeless, durable, unremarkable to anyone not looking closely. And that's the point where people look at 3i Atlas and let their imagination stretch a little. If someone were hiding probes inside comet-like shells, they think, wouldn't an interstellar comet be a perfect disguise? Avi Loeb, one of the most open-minded astrophysicists alive today, has spoken publicly about such possibilities, not as facts, but as thought experiments. He has argued that interstellar objects deserve to be examined with curiosity rather than dismissal. He has suggested that in theory, a visitor like Atlas could release smaller probes as it passes through a solar system, especially in regions with gravitational advantages like the outskirts near Jupiter. Not because he claims this is happening, but because he argues we shouldn't be afraid to ask. In his words, extraordinary claims require extraordinary evidence, but we won't find anything if we refuse to look. But now we return to the responsible part of the story, the grounded part. There is no evidence that 3-Eye Atlas is anything other than a natural object. None. No radio transmissions, no anomalous thrust patterns, no unnatural changes in speed, no thermal signatures that suggest machinery hiding beneath the ice. If someone wanted to plant a probe in our solar system, billions of years of cosmic radiation would have destroyed delicate hardware long before it got here. The tiny impacts of interstellar dust grains would have chipped away at any precise structure. The heating near the sun would break apart anything engineered without extreme protection. The tidal forces from giant planets would pull at its body, and the violent outgassing during perihelion would rip open any fragile compartment. If there were something hidden in 3-Eye Atlas, the galaxy itself would have shredded it long before your species learned how to farm. But still, your imagination wonders. It imagines a frozen probe sleeping inside an icy shell. It imagines a device designed not for communication, but for observation. It imagines something that awakens only when it detects the radio leakage of a young civilization broadcasting into space without realizing it. It imagines a scenario where the universe is listening, quietly, patiently. And then we gently close that door. Because imagining is fun. But mistaking imagination for fact is where grown-ups must draw the line. Wondering is human. Declaring without evidence is not. It's important to keep both feet on the ground here. The universe is already strange enough without needing extraterrestrial engineering to make it interesting. Interstellar comets alone carry mysteries. Their chemistry, their age, their fragmentation history, their ejection stories. They are physical postcards from star systems you will never see with your own eyes. That alone is astonishing. That alone is worth staying up to watch. The truth is, the universe doesn't need aliens to be magical. It already is. The dark forest idea is a powerful lens. Loeb's wildcard thinking keeps the scientific world honest. But when you put the speculation aside, what remains is still beautiful. A visitor from another star, older than your sun, drifting through your neighborhood for one night before disappearing forever. You don't need to turn it into a spaceship to feel awe. Look at it for what it already is. A piece of galactic history illuminated by your star as it passes through. Something your ancestors could never have imagined. Something your descendants will never see again. Something slipping into your evening like a quiet reminder that the universe exceeds your expectations even when it obeys all the rules. So yes, it's okay to wonder if someone else is out there. That's part of being human. But it's also part of being human to separate what we want to imagine from what the evidence actually shows. And on December 19th, the evidence will be rich enough without needing to borrow from science fiction. Even our wildest ideas will lead us back to something real, something we can measure, something we can understand, step by step, as Atlas makes its closest pass. Wild ideas are fun, but the real story of Atlas is even bigger. It's not just about one comet. It's about the kind of galaxy we really live in. If you've been following Atlas from the start, it's easy to think of it as a singular event, a rare, isolated moment in time. But when you zoom out, when you widen the frame to the scale of the galaxy, something surprising becomes clear. Atlas is not an exception. It's part of a pattern, a signal that we are entering a new era of astronomy, one your grandparents could never have imagined, and one your grandchildren may take for granted. Atlas is the third interstellar visitor we've ever seen, and each of the three carries its own story. The first was One-Eye Oumuamua in 2017, a strange, elongated object moving faster than anything we had tracked before. It brightened oddly. It dimmed oddly. Its shape was unclear. And most famously, it accelerated ever so slightly in a way we still can't fully explain using normal comet outgassing. Some people argued for exotic explanations. Some argued for better models. But everyone agreed. It was unlike anything we'd seen. Then came 2I Borisov in 2019, a more familiar kind of comet, but one that looked pristine, as though it had been frozen in darkness for billions of years without ever passing near a star. It was clean in a way local comets rarely are. It carried chemistry that hinted at a quiet, untouched life drifting between suns. And now, 3I Atlas in 2025, larger than Borisov, brighter than Oumuamua, older than both, and rich with data. It's giving us a long, detailed look at what interstellar debris really looks like. Not a brief flash, not a mysterious blur. A fully observable comet, moving slowly enough across the sky that the world can watch it from multiple angles for months. One visitor from another star was extraordinary. 2 was startling. 3, in less than 10 years, tells a different story. For generations, astronomers assumed interstellar visitors would be so rare that we might never see one in a human lifetime. The galaxy is vast, the distances enormous, the odds tiny. And yet here we are, standing in a decade that has seen 3 of them glide through our neighborhood, like travelers passing a gas station on a long highway. Why? Because our eyes have changed? Modern sky surveys have multiplied our search power by orders of magnitude. Pan-STARRS in Hawaii, Atlas spanning Hawaii, Chile, and South Africa, Zwicky Transient Facility in California, and soon, the Vera Rubin Observatory coming online, set to scan the entire visible sky every few nights with unprecedented depth and speed. We didn't suddenly become lucky. We simply got better at noticing what was already happening. It's like switching from driving at night with your headlights off to turning them on full beam. The road was always there. You just couldn't see the traffic. Think of the galaxy as a massive ancient highway. Star systems form. They evolve. They interact. Sometimes they eject debris, comets, asteroids, frozen fragments of failed planets, and those fragments drift. They drift for millions, sometimes billions, of years, following paths shaped by nothing but gravity and time. They cross the spiral arms. They weave between stars. Some pass close to worlds without being noticed. Others fall into distant suns. Most wander forever. The solar system, from this perspective, is not a quiet cul-de-sac. It's a random pull-off on a dark interstate. Objects don't come here with intention, but they do pass through. Not often, but often enough that if you watch carefully, with modern instruments and global cooperation, you will see them. Astronomers estimate that within a sphere just 1 parsec wide, a little over 3 light years, there may be millions of interstellar objects, not one, not a handful, Millions. Most tiny. Most faint. Most invisible to us. But every few years, one grows bright enough, or comes close enough, or crosses a favorable angle, and it enters our awareness. If each interstellar object is a vehicle, then the Milky Way is a 24/7 interstate system stretching across 100,000 light years. Our solar system sits beside one of the exits, not special, not central, but positioned well enough that every now and then we see someone drive past. And here's the part that should make you stop for a moment. Even in the middle of your normal day, you are living in the exact era when humanity finally turned on the radar and realized the highway is busy. Every generation before you lived in the dark. Your generation is the first to see the traffic. Michio Kaku once said, "We are now entering the golden age of astronomy." He wasn't exaggerating. With every new survey, every new camera, every new algorithm that searches the sky for movement, we detect things that were invisible even 10 years ago. And Atlas is the proof, not that interstellar visitors are rare, but that we are finally able to see them. In that sense, Atlas is not a punctuation mark. It's a chapter heading, a signal that the study of interstellar debris, real material from other planets and other suns, is becoming a field of its own. Soon, we won't just watch these visitors. We'll classify them. We'll compare them. We'll build statistical models of their chemistry, their ages, their trajectories. We may even send missions to them someday. So when you watch Atlas on December 19th, you're not just watching a comet. You're watching the universe pull back a curtain that has been closed for most of human history. You're watching evidence that our planet is not isolated, not alone, not sheltered from the currents of the galaxy. For the first time, humanity is beginning to see the galactic highway. And once you see the highway, the natural next question is, what does all this actually mean for us? Not just as a planet, but as people living our ordinary lives under an extraordinary sky. But what does this passing visitor actually mean for us? Not just as a planet, but as people. Picture this. It's a cold December night. You've finished work. The emails are finally done. The house is quieted down. You pour yourself a cup of hot tea, or maybe a small glass of whiskey if the day was long. You sit down, settle into your favorite chair, and pull up the live stream. On the screen, a small gray smudge drifting across a field of stars. The caption reads, "Live, 3EI Atlas, interstellar comet, closest approach to Earth." You watch the frame, the slow movement, the commentary from astronomers. And somewhere in that stillness, a question rises, not about the comet, but about you. When Atlas passes by our world, what does it say about us? It's here that the story shifts, gently, from science to something more human. Because December 19th is not just about what 3i Atlas is. It's about what its visit reveals about the people watching it. Over thousands of years, humanity's relationship with comets has changed more than the comets themselves ever have. And that change tells you something important about who you are now, especially if you're a man in your 40s, balancing work, family, responsibility, and the quiet hunger for meaning. There are 3 parts of ourselves that a night like December 19th brings into focus. First, curiosity. Thousands of years ago, a comet in the sky meant fear, panic, superstition. Leaders trembled. Farmers prayed. The world looked up with dread, not wonder. But you're watching from your couch, not your cave. Instead of fearing an omen, you're opening a live stream. Instead of worrying about divine punishment, you're listening to the chemical breakdown of a visitor from another star system. Humanity has walked a long road from superstition to science. And the simple act of watching Atlas calmly, gently, without fear, is proof of how far we've come. Curiosity has replaced panic. Knowledge has replaced myth. You are part of that quiet evolution. Second, patience and understanding. Our ancestors saw comets once in a lifetime and wrapped entire belief systems around them. Today, you watch experts analyze spectra, debate outgassing patterns, argue over coma brightness, compare models, revisit predictions. You watch as scientists question each other, challenge assumptions, and revise conclusions without collapsing into fear. That's maturity. It's the ability to observe something strange without assuming disaster. It's the discipline to say, let's measure first. Let's think. Let's talk. And maybe that resonates with you more than you realize. You've had enough years of life to know that not everything unknown is a threat. Not every surprise is a crisis. Sometimes you just sit with the mystery and let it unfold. Third, humility. Atlas is older than the sun, older than Earth, older than every mountain, every ocean, every fossil, every story humans have ever told. It was born in a star system you will never see, shaped by forces you will never touch. And yet here it is, briefly brushing the outer light of your world, passing through your neighborhood like a traveler making an unplanned stop. Humility isn't weakness, it's perspective. It's the reminder that your daily pressures, the meetings, the deadlines, the bills, the frustrations, all sit on a tiny rock in a galaxy that doesn't even know your name. And somehow, that makes everything feel a little lighter. You may have a mortgage, responsibilities, aging parents, a career that pulls at you, and days when you feel stretched thin. But tonight, you also have something extraordinary. The chance to witness an object that began its journey before Earth existed. You can sit back in your chair, in the quiet of your home, and watch a piece of cosmic time drift by. For a moment, the boy inside you, the one who loved dinosaurs, space books, night skies, comes back. Not loudly, not with fireworks, but with a soft nudge that reminds you you're still capable of wonder. And that's the quiet beauty of December 19th. It's not a day that changes the world. It's a day that quietly proves the world has already changed. In ancient times, a comet could start wars. Tonight, it starts conversations. Back then, people feared losing control of their destiny. Tonight, you gain a moment of clarity about your place in the cosmos. You're not watching a threat. You're watching a reminder that life is bigger than stress, that curiosity never has to fade, that the universe is vast but peaceful, and that you're part of a species learning to look up with calm intelligence rather than terror. The truth is, the comet isn't here to test Earth. It's here to test us, to ask whether we respond with fear or understanding, with panic or patience, with noise or quiet wonder. And the way you choose to watch it, calmly, thoughtfully, without superstition, says something about how far you've come as a person. Carl Sagan once said, "We are a way for the cosmos to know itself." On December 19th, that will be literally true. As you sit there, drink in hand, watching that gray smudge drift across a distant star field, you are participating in the universe, learning a little more about its own story. You are a witness, a participant, a momentary reflection of something ancient passing by. You're not just watching the universe. The universe is watching how you respond. And soon, Atlas will be gone, leaving only the trail of what it taught us. After December 19th, something subtle begins to happen. Something that doesn't make headlines, doesn't trigger live streams, doesn't even register for most people going about their holiday routines. But you, who have been following this visitor for months, will notice it. You'll feel it, like the last notes of a song fading into the air long after the instruments have stopped playing. Atlas begins to dim. Not suddenly, not dramatically, just gently, night by night. Its light, once boosted by solar heat and the activity of dust and gas boiling from its surface, begins to settle back down. The jets quiet. The coma contracts. The tail, once bright enough to show up even on mid-range telescopes, thins until it looks like the faintest paintbrush stroke on the canvas of the sky. The show isn't over. It's simply winding down. Atlas continues its flight, moving away from the sun and back toward the cold. It leaves the crowded, warm inner regions of the solar system and begins drifting upward, away from the planetary plane. The thin, shared highway where Earth, Mars, Jupiter, and the rest travel in their long, elegant orbits. Slowly, almost imperceptibly, Atlas rises out of that lane and into a steeper, lonelier path. Ahead lies a long stretch of darkness, far beyond Jupiter, far beyond the reach of any solar-powered probe, far beyond the last thin boundary where the sun's gravity still tugs more strongly than the pull of the galaxy. It will take years for Atlas to cross that invisible frontier, the point where the sun becomes just another star. When it does, the object will return to the same environment it lived in for billions of years before arriving here. The interstellar medium. A place without warmth, without pressure, without the familiar comforts of planetary light. A cold so deep, it becomes a kind of silence. A darkness so complete, it becomes a home. And in that vast emptiness, Atlas will simply keep going. No destination, no return date, just motion. A visitor passing through, leaving us wondering what worlds it came from and what worlds it will pass next. Perhaps the most beautiful way to imagine it is like this. A traveler from far away stopped by your porch for a brief moment, long enough to let you ask questions, long enough to leave you thinking, long enough to remind you there are roads you've never seen. And then, without ceremony, it steps off the porch and continues walking into the night. And strangely, that image resonates deeply with men in their 40s. You've had people enter your life unexpectedly. A mentor at work, a friend from a different chapter, someone who taught you something, or even someone who challenged your assumptions. They arrive without warning, stay for a season, leave quietly, and somehow the room still feels different after they're gone. Atlas is like that, a reminder that not all meaningful connections are permanent. Some matter precisely because they're brief. The data it leaves behind, the spectra, the images, the trajectory models, the chemical signatures, the anomalies and confirmations, will be studied for decades. Students not yet born will read about Atlas in textbooks. Future astronomers will analyze its dust, its brightness curve, its behavior near perihelion. It will become a case study, a chapter in the story of interstellar science, a benchmark against which new visitors will be compared. But for you, the person who watched it in real time, Atlas becomes something else, a memory, a story you were present for, a moment in your life when you stepped outside the noise, looked up, and saw a piece of another star system drift by. There's a quiet pride in that. Not loud, not boastful, just the warmth of having witnessed something rare, and knowing that rarity won't return. And then comes the silence. As Atlas fades, the sky returns to its usual rhythm. Stars reclaim the stage. The constellations settle back into their familiar shapes. Life goes on, but somewhere in the back of your mind, you still feel the trail of that visitor. A thin line of wonder stretching behind it, like the last streak of a meteor you almost didn't catch. Some visitors leave quietly, but change the house after they've gone. Atlas is one of them. And in that quiet departure, something new begins, not out there in the sky, but inside you. Because the moment the object fades beyond view, you are left with the one question that matters most. And now, with the universe quiet again, what does this silence tell us? Now the sky settles, the excitement fades, and somewhere far beyond the warmth of the inner solar system, Atlas continues drifting into the cold. Its glow, once bright enough to pull astronomers into all-night shifts, once sharp enough to stir curiosity across the world, softens into the darkness. The coma thins, the tail dissolves, and the last scattered dust catches the very last traces of sunlight before disappearing completely. It becomes what it has always been, a traveler moving through a universe that rarely announces its footsteps. And as it slips away, the night becomes still again. Quiet, spacious, familiar. This is where we end the story. Not with a bang, not with certainty, but with the kind of silence that feels almost like a blanket being laid gently across your shoulders. Take a slow breath. Let it settle. Let the weight of this long journey loosen its grip. Because now, with Atlas fading, you can finally look back on everything you've followed. You watched it approach Mars. You watched it brighten. You watched it slip behind the sun and emerge again. You watched it with scientists, with enthusiasts, with strangers across the world. All of you sharing a moment no generation before could ever have witnessed. You've seen the things we understood. You've seen the things we didn't. You've heard the debates, the numbers, the speculations, the quiet acknowledgments that the universe is stranger and older than the models we sketch on whiteboards. There were things we hoped to find out. There were things we didn't expect at all. And there are still questions, open, inviting, not threatening. Questions are the universe's way of asking us to stay curious. Answers come slowly, like comets drifting in from the dark. And if you felt fear at any point in this journey, even the soft kind, the kind that hides in the back of your mind, it's worth understanding something quietly profound. Fear is just another word for respect. Respect for the unknown. Respect for forces older than your planet. Respect for the possibility that there is still so much left to learn. But fear does not mean danger. Curiosity does not mean risk. And mystery does not mean threat. Tonight, and every night surrounding December 19th, you are safe. Earth is safe. Your family, your home, your life, your tomorrow. All untouched by this visitor of ice and time. Nothing about Atlas threatens the world you live in. Nothing about it requires dread. Nothing about this moment asks you to brace. Quite the opposite. The worst-case scenario was never, "What will happen to Earth?" It was always, "What will we learn about ourselves?" Worst case means the universe refuses to fit inside the old lines we drew for it. Worst case means our understanding must expand, not collapse. Worst case means we remember once again how young we are in this vast cosmic ocean. And strangely, beautifully, that is not frightening. It is freeing. Being small does not make you insignificant. Being small means you are part of something grand, something patient, something serene. Being small means you can let go a little. Let the world spin. Let the night stretch. Let the universe hold the things too large for your shoulders. So breathe. Feel the quiet. Notice how the room softens when you stop reaching for answers and simply sit with the stars for a moment. Outside, the winter sky of the American night is calm. The air is cold, steady. The constellations hang like old companions. There is no rush here, no noise, just a world turning under a blanket of quiet light. You've spent this time listening to the story of a visitor from another star, older than Earth, older than every mountain and every river you've ever known. And still, after all the wonder and all the mystery, the message it leaves behind is gentle. You are safe. The universe is quiet tonight. You don't need to worry about December 19th. You don't need to brace for anything. You don't need to solve every open question before falling asleep. All you need is this moment, this breath, this calm. The universe has been around for billions of years. It will be here tomorrow. You will wake under the same sky, a sky unchanged by the passing of one more comet. Let your thoughts slow. Let your shoulders drop. Let the noise of the day fade out. Let the dark become soft instead of heavy. Let yourself drift the way Atlas drifts, unhurried, unafraid, moving through familiar darkness with a quiet kind of purpose. Carl Sagan once said, "We are a way for the cosmos to know itself." Tonight, you have lived that truth. You have looked outward and inward at the same time. You have allowed yourself to feel small, and because of that, you have felt free. Neil deGrasse Tyson once added, "We are part of this universe. We are in this universe. But perhaps more important, the universe is in us." And that is the feeling you carry now. Not fear, not tension, but connection. Atlas has moved on. Its trail is fading, but the quiet it leaves behind is yours to rest in. So, as you settle deeper into your chair, or your bed, or the warm stillness of your room, let the last words drift to you, the way a comet's tail drifts across the night sky. Slow, soft, certain. Good night, traveler. The universe is quiet tonight.